Hey guys, welcome back to another video of 7A Math with Nathan the Tugan. So for this video we're going over 4.2, and 4.2 is all about greatest common factor. Now this by itself is pretty confusing to some people. Again, if you know how to do factors, you should be able to do greatest common factor. And the most confusing part of this is not finding the greatest common factor, is, is when we use it on conjunction with the fractions and things like that. A lot of people will confuse on this and another tool that we'll learn later, but let's go focus on greatest common factor. So let's recall factors are number we can multiply together to get another number. So 4 times 10 is equals to 40. 4 and 10 are what we call factors of 40. And here's the thing about factors. Factors also means that if we divide a number with its factor, we won't get any decimal or remainder. So if we divide 40 with 4, we're not going to get any decimal or remainders. And that's true because our answer is going to be 10. And when we divide 40 with 10, because that's also a factor of 40, we'll get 4. As you can see, no remainders. Now, let's have some examples. Let's list all the factors of 12 and 30. So let's start with 12. So the first factor of all numbers is 1. And then this one is 2, 3, 4, 6, and 12. And then 30 is 1 times 15, 1 times 30, 2 times 15, and then 3 times 10, and then 5 times 6. So those are all the factors of 30. You can see when you compare the top and the bottom, they share some numbers, right? And those numbers that they both share are what we call common factors. So let's list the common factors of 12 and 30. It's 1, 2, 3, no 4, no 5, 6, and then 12, and then that's it. So those are all the common factors of 12 and 30. 1, 2, and 3, and 6. Now, hopefully you guys, by now, you should know what is, okay, I went ahead on that. Again, here's the definition of a common factor. Common factor is a whole number that is a factor of 2 or more whole numbers. So as you can see, you can have, you guys are sometimes given more than 2 numbers. Sometimes you're given 4 or 5. But in this case, for now, you're only going to be given up to 3 numbers. 15, 30, and 105. So let's start finding let's do find the common factors of 15, 30, and 105. So let's start with 15. 15 is basically 1 times 15, and then 3 times 5. Is that all the factors of 15? Yes, those are all the factors. Nope, no number here. 30 is 1 and 30, 2 and 15, 3 and 10, and 5 and 6. How about 105? 105 is 1, 3, 5, 7, 15, 21, 35, and 105. Now let's list all the common factors of them. Obviously it's going to be 1, 3, 5, and is that all? Nope, they all share 15. So here's your final answer. 1, 3, 5, and 15. So by now, you should be able to know how are you going to find greatest common factors. Greatest common factor, or GCF for short, is the largest of the common factors of two or more numbers. So here was the greatest common factor. It's 15 because it's the biggest of them all. Now there's two ways of finding GCF. The first method is the one we just did. List all the factors of each number and then they identify the greatest number that is on every list. So let's have and step another way. If you didn't want to do all that, if you're not good with multiplication, your multiplication table is a subpar, you can use this method, and this is using prime factorization. So first step is you're going to write the prime factorization of each number, and then the GCF is the product of the common prime factors. So again, common prime factors means prime factors they all share. All the numbers share. So let's have an example how all this works. So 24, 60, and 36, you want to find the GCF. So let's list the factors of 24. First number is 1, 2, 3, 4, 6, 12, and 24. Again, 1 and 24, 2 and 12, 3 and 1 times 24, 2 times 12, and then, oh my bad, I forgot one number, 8 and 6, 3 times 8 is 24, 4 times 6 is 24. I forgot a list on that. 60 is 1, 2, 3, 4, 6, 8, oh, that's why. Sorry about that. Instead of 60, we'll use 72. And let's list all the factors. 6, 8, 9, 12, 18, 24, 36, 72. Okay, this is 72, my bad on that. And the last one is 48, which is, oh, it's not 36, 48. I'm sorry, guys, I just mistyped on this. 48 is 1, 2, 3, 4, 6, 8, 12, 16, and 24. So if you compare it all, they share all ones, all twos, all threes, all fours, all six, all eights, 12, but the highest one is 24. So your GCF is 24. Now let's have another example, 24, 60, and 36, when this time, again, my bad on this is 72 and this is 48. But this time we're going to do the prime factorization of each number. So 24, again you can do your factor tree on the scratch of paper, 2, 12, 2, 6, and then 2 and 3. So 24 is 2 times 2 times 2 times 3. 78 is, if we do this correctly, you're going to have 2 times 2 times 2 times 3 times 3 and 7. 48 is 2 times 2 times 2 times 2 times 3. And what you're going to do is you're going to find the common prime factor they all share. So we have 1 2's, another 2, and then another 2, and then one group of 3. And what you're going to do is this one, all this represent 1 2. All this represent 1 2. All this represent 1 2, and all this represents 1 3. And what you're going to do is multiply all this. 2 times 2, 4 times 2, 8 times 3 is 24. So your GCF is 24. So if you're not good with multiplication, go with prime factorization. Because this one you're only going to divide with small numbers, and hopefully you know how to divide small numbers. So now, hopefully no questions with GCF. If you have any questions, please type in the chat. Anyway, let's move on to our last topic for GCF. What is relatively prime? Hopefully you remember what prime is, right? Prime number are numbers that have 2 pair of factors, only have 2 pairs, one in itself. So what is relatively prime? Well, relatively prime are 2 or more numbers are relatively prime if their greatest common factor is 1. So basically, you need to find the GCF, and if the GCF is 1, those numbers are relatively prime. That's the only way to know if a set of numbers are relatively prime. Let's have an example. 16 and 35. So let's go list. You were gonna use the listing method. 16 and then 35 on the bottom. 16 is 1 and 16, 2 and then 8, and then we have 4 times 4, so it's just 4. And 35 is simply 1 and 35, and 5 and 7. What is the GCF of this? GCF is 1, so relatively prime. And then another example, 45 and 35, but in this case we're going to do method 2, prime factorization, to find the GCF. So 45 is simply 3 times 3 times 5, and 35 is simply 5 times 7. As you can see, they share 5. Their GCF is simply 5, because just 1 5, we're not going to multiply anything with it. So straight out, your GCF is 5. Is GCF 1 or 5? The GCF is 5, so that means not relatively prime. So we're skipping some hard things. So we're not gonna find GCF of one of numbers with variables in it. That's too advanced for you guys. So you guys need to just focus on GCF. When you're 8th grade, you're going to find GCF with variables. Fun stuff. Anyway, hopefully you this is the end of the video. Hopefully you have learned a lot. I'll see you next time. Goodbye.